Which of the following converts fibrinogen into fibrin? And when we look at these terms, fibrinogen into fibrin, it's converted from one to the other for the process of blood clotting. So anytime you see fibrinogen, you want to think about a blood clot, meaning that if there's a break in the skin and there's bleeding, how does that bleeding stop and eventually scab up? So fibrinogen, this is a soluble plasma protein. So soluble, meaning it could be dissolved in water. It's a soluble plasma glycoprotein, and it's produced in the liver. Then fibrin, what it's converted to, is insoluble. So this one would be insoluble protein. And it forms the structural basis of the blood clot. So we need to get from fibrinogen to fibrin in order for the blood to clot. Now, this activation from the fibrinogen into the fibrin is caused by thrombin. But this question wants you to think about it a little deeper because, as you can see, thrombin is not a choice. So we want to think, out of these choices, which of these would lead to the thrombin to activate fibrinogen into fibrin in order to cause the blood clot. So let's see if there's any that we can eliminate. When we see eosinophils, basophils, these are types of white blood cells that have specific purposes. Eosinophils with allergic response, basophils have to do with the inflammatory response. So we have lymphocytes, which also have to do with an immune reaction. And we have platelets, which we know is directly involved with clotting. Platelets are the part of the blood that form together in order to clot blood to stop bleeding. And that's why we get concerned if a patient has too high or too low platelets, because we don't want excessive bleeding, but we also don't want clotting where there shouldn't be clotting, so we have proper blood flow. So therefore, platelets are directly related to the blood clotting process, just like fibrinogen and fibrin. So how would platelets cause the conversion of fibrinogen into fibrin? Well, how it works is that while platelets, they have two roles in this scenario. One would be the platelets themselves stopping the bleed. So platelets stopping the bleed. It's kind of like a whistle blow whenever there's a notice that there's bleeding in the body, that there's a cut that needs to be stopped. The platelets all get signaled and come together and form sort of a stickiness that prevents the bleeding. So if let's say that this is the skin and this is where the cut is, the platelets will kind of mesh together here. Let's say these are the platelets to prevent the bleeding. But then the step 2 on how we have that relation to the fibrinogen converting to the fibrin via platelet route is that the platelets also activate a signaling cascade. So activate signaling cascade, and this activation allows for the conversion of fibrinogen into fibrin, and the thrombin would be part of this process, but it's the platelets that helps for this conversion to occur. So just thinking of it from two ways, we know that the actual definitional of what is converting fibrinogen to fibrin would be thrombin, but then based on these choices, another way to look at it would be which of these would signal this process, which ultimately also leads to thrombin converting fibrinogen to fibrin, and that would be the platelets activating the signaling process, which is choice D.